Hi, my name is Parker Greep, and this is an Introduction to Recursion Part 1 for Mr. LaRocca's AP Computer Science class. By now, you should be starting to learn about recursion, and this video is just supposed to help you learn about recursion because it's a pretty complex idea and it's pretty difficult to code and understand when you see it. First, let's just talk about the definition of recursion. What is recursion? Well, it follows three rules. The first being that recursion occurs when a method calls itself. The second is that recursive methods will become simpler as they progress. And you'll see exactly what I'm talking about when I show you an example. The third is once a method is in its simplest form, it references a base case. Over here we have an example of a recursive method called sum, and it returns the sum of all numbers from 1 to x. So if we did sum of 3, it would return 6 because 1 plus 2 plus 3 is equal to 6. Um, let's take a look at how these rules apply to this recursive method. Right here, this return statement, um, this is what defines sum as a recursive method. It's because the method sum calls itself in its body, in the method body. You'll see sum right here, and you'll see sum right here. Sum calls itself, and then this sum will also call itself, and it's going to keep calling it, and that's why we have a base case right here. Is because when we keep calling sum, if we do sum of 3, it's going to keep getting closer to 1. It's going to become simpler and simpler until it's at its most simplest form when it's at 1, and it'll return 1. If you aren't really following me, be patient. I'm going to go over it right now. Let me get rid of all this from a previous time. Okay, how does this method work, this recursive method? Well, if we wanted to find sum of 3, we could just check. Well, sum of 3 is going to, let's just check our method, sum of 3. So x is going to be equal to 3. First we check to see if x is equal to 1. Well, it's not because it's going to be equal to 3. So we can skip this. And we go here and we return x plus sum of x minus 1. So under sum minus 3, we can just do 3 plus sum 2. And sum of 2 is going to be simpler because it's going to be closer to our base case. And you'll see what our base case is soon. Sum of 2. Well, let's go over here and just check. X is going to be equal to 2. Is x equal to 1? No, it's equal to 2. So we go to this statement and return x plus sum of x minus 1. So for sum of 2, that's going to be equal to 2 plus sum of 1. And sum of 1 is going to be our recursive method in its simplest form because it follows the base case. So if we do sum of x and we set x to 1, first we check to see if x is equal to 1, and it is, so we just return 1. We don't call the method again. So we just return 1. So we don't need to add anything onto 1. It's just 1. So we can collapse this to just be 3 plus 2 plus 1, because sum of 2 is equal to 2 plus 1, and sum of 3 is equal to 3 plus 2 plus 1. And 3 plus 2 plus 1 is equal to 6. And that's going to be sort of how we map out our recursive methods on paper. It takes a long time to do that with more advanced versions of recursion, and I'll talk about the types of recursion next. But the difficult thing about recursion is just mapping it out. Understanding it and reading it isn't that difficult. There are types of recursion. Recursion comes in several types of forms that I'll be covering in this series of webcasts. There's single recursion, which is what we just did. where the method only calls itself once. There's multi-recursion, where instead of just calling it once, it'll call the same method multiple times, and I'll give you examples of that, and we'll do a couple of problems with that. There's also class or multiple method recursion, which is very complicated. I'm still trying to understand it. It's when you have two recursive methods and that they call each other and they'll both work with each other and they'll uh, it gets very messy really quickly. But if you can do recursion, and I'll explain that in a separate video of why we use recursion and why recursion is the better alternative to for loops and other ways of looping, um, this type of recursion becomes very useful. Um, I'm going to cut off the video right here because I just wanted this to be an introductory video to recursion, and in my other videos I'll go over why we use recursion, as I said before, and a whole bunch of different problems to help you get familiar with recursion, get you started solving problems with recursion on your own. Um, I'm gonna leave it off at this, and I hope you guys check out my other videos.